This is the end of quarter update for spring of 2020. I'm Olivia and my research partner is Zev, and our project is Metacognitive Reflection. We are a part of Agile Research Studios, which helps students self-direct their own research. Self-directing research can be very difficult, and metacognitive skills can help students perform the self-regulation necessary to conduct self-directed research effectively, which consists of 3 parts: planning, reflection, and performance.
Our users were undergraduate researchers in the Design, Technology, and Research program at Northwestern. These were undergraduates who are self-directing their own HCI research projects. Our project works to first promote the continuous and actionable reflection of students, second, connect students to strategies practiced across their community, and third, to model their growth and development over time.
Previous to our work in this project, research had been focused on Muse, a Slack bot which prompted users through a reflective scaffolding. At the end of last quarter, we decided to take our project in a direction that incorporates the capture of mentor feedback on a student's process. This involved developing 3 design arguments consisting of a student preparing to meet with their mentor, a student capturing the feedback their mentor provides on their process, and a scaffolding a reflection based on that feedback. We decided to focus on the slice of our design argument related to the capturing of feedback. Our desired outcomes are, during the feedback session, students want to 1. Align their understanding of their blocker with their mentor's assessment of their blocker, and 2. Capture any feedback that a mentor provides regarding their process and thinking, filtering that feedback from project feedback before reflection.
The obstacles that we came across through need finding and user testing were 1. That students don't push back or question their mentor when they are confused, which creates a misalignment between what their mentor thinks and what they think. And second, that student and mentors get deep into discussion about project details and mentors do not provide metacognitive feedback. This is a quick meta-analysis of sorts where we tried to isolate the obstacles for each user class. So some of the variables that we care about were whether or not a team was made up of a solo student or a pair, and whether or not those students were novice or experts. This is by no means comprehensive, and we have more work to do in user testing. And there's also other variables that we might care about, like what stage of the quarter it is, or what type of interaction it is, like whether or not it's SIG or LIP.
Our core design characteristics use a record, then filter model for capturing mentor feedback. During the meeting, the student will write down all of the feedback their mentor provides for them in one column. After the interaction, the student will organize the points into their corresponding sections. The first one being metacognitive feedback. Students will write any feedback their mentor provides regarding their metacognition that helps them improve at the process of doing research. For example, you need to be communicating with your partner better, or you need to be help seeking more. Second, students will write any practical advice about solving a conceptual or practical problem in their projects. For example, reword the language of your 8-pack to better express your system arguments. They can then use these notes to summarize their mentor's assessment of their blocker and reword in comparison to their previous articulation. Additionally, there is a box for students to record feedback that was unclear to them so that they can address it at a later time. Initially, our core design characteristics used a record and filter model. Prior to meeting with their mentors, students would answer questions about their focus for this sprint and their biggest risk, also prompting them to consider the type of risk they were facing and how it was preventing them from making progress. During the interaction with their mentors, students would take notes in the following sections: metacognitive feedback, or feedback a mentor provides about a student's process; project feedback, or feedback about practical or conceptual blockers a student's facing in their project; and the third column is for feedback about a blocker that a student is currently facing. We've also included a student's articulation of their biggest risk for reference, and a space at the bottom for feedback that the mentor gave that was unclear to the student. After the interaction, students would revise their articulation of their blocker here and answer some questions for us about usability.
Our first round of user testing was performed with prototype 1, and we performed a total of 3 user tests on 4 students. So some of the takeaways that we found were that the disparity in obstacles for user classes existed more in the single pair attribute and less in the novice expert attribute. We found that single students found it difficult to filter feedback in action, and students in pairs found it difficult to participate in their SIG meeting because of the cognitive work that's required to filter. And then we also found that filtering afterwards still satisfies our desired outcomes while allowing students to focus on the meeting and write high quality notes. So instead of them doing that during the meeting, we just had them do it afterwards. And from the feedback we got and the results, it was a much better. I'm going to take a moment now and go through what we did for our second prototype. So the first page here in the pre-slice is the same as what we did for the first prototype. They can choose what type of blocker they have and articulate it down here. This is different. What we did here is we provided a space for a student to write anything at all that they might record during a meeting. So here they can write something like, communicate more over Slack, system and interface arguments overlap. And they can just kind of take it all the way down here throughout the meeting. And then after the meeting, they'll sort of cut and paste this. So communicate more over Slack would go in the metacognitive column, and system and interface arguments overlapping would be more project-based. And then over here, they have space where they can summarize and synthesize their notes on the mentor's assessment using these notes here and the risk here.
In our second round of user testing, we performed a total of 5 user tests on 7 students. Students confirmed that filtering feedback afterwards was easier for them. We also learned that eliminating the separation between blocker feedback and project feedback addressed confusion between the two and allowed students to be more reflective about their mentor's assessment of their risk. We're excited for our next steps in this project. We intend to continue testing our capture and filter model, and we hope to increase our understanding of the next slice of our design arguments regarding post-interaction reflection through need finding. Eventually, we intend to expand our prototype to incorporate this slice.
Some takeaways from the quarter that we found were that it's important to prioritize iteration over perfectionism in design arguments, prototyping, and user testing. Our design needs to support a variety of contexts and users across learning styles, stage of their project, whether or not it's solo or pair, whether or not they're novice or expert, and even the type of interaction, whether it's SIG, MISO, or office hours. We also found that there's a point where iterating on an argument doesn't really further project progress, and that testing is the only way to get helpful information. And we found that it's important not to force higher fidelity prototypes if it doesn't get you any closer to achieving your desired outcomes. Thank you.